Hello, everyone, and welcome to a special Friday edition of Airway Circle's Thursday Night Live. I'm Madison, and I'm going to be your host today. And I have with us Dr. Nathan Bryan, and he is a leading expert in nitric oxide biochemistry with over 25 years of research experience. And he earned his Bachelor's of Science in Biochemistry from the University of Texas in Austin, and his Ph.D. from LSU's School of Medicine, receiving the Dean's Award for Excellence in Research as well. After a post-doctoral fellowship at Boston University, he joined the University of Texas Health and Science Center under Nobel Laureate Dr. Ferid Murad. As founder and CEO of Bryan Therapeutics, he develops nitric oxide-based therapies for heart disease, Alzheimer's, and wound healing. His consumer products are widely recognized, and his research continues to shape the future of nitric oxide science, improving health worldwide. Welcome, Dr. Bryan. We are so happy to have you today and to talk a little bit more about nitric oxide and the oral systemic link. I will let you take it away.
Madison.
Yes.
Thanks so much for having me. And again, let me apologize for my attire. I'm usually more professional when I do these webinars, but my flight was delayed and I got stuck in the middle, so I'm still in my travel attire. But so my apologies for my appearance. But no, what I thought we would do is just spend the next 45 minutes kind of giving you really, I think, hopefully an understanding of nitric oxide signaling and production in the body. These are my conflicts of interest. I've started a number of companies. I receive royalties from patents. But really, the objectives are to learn nitric oxide signaling in the human body, describe how the oral microbiome and how it produces nitric oxide and contributes to blood pressure regulation. But really dealing with, oral hygienic professionals is to really reveal what disrupts the microbiome, shuts down nitric oxide production, leading to chronic disease. And then at the end, I'll show you the therapeutic and nutritional strategies to restore nitric oxide production in patients. So really give you the tools you need to make your patients better. And the most common question I get is, being in science and basic science, why study nitric oxide and only nitric oxide? Well, when I started in the field 25 years ago, it was known that most chronic diseases are associated with an impaired production or nitric oxide deficiency. So at the time, there were really no analytical methods to determine and detect nitric oxide in biological samples. So that really started my journey in trying to figure out how do we develop analytical methods where we can really create a fingerprint of NO biology in different diseases, from heart disease, erectile dysfunction, diabetes, Alzheimer's. And once we understood that, then we could start to rationalize, develop rational therapies for many different diseases. But I want to start kind of broadly speaking, because what I've learned in 25 years in academia and in teaching science and medicine is that chronic disease, loss of nitric oxide leads to chronic disease. And the hallmarks of chronic disease are hypoxia and ischemia, meaning that there's decreased blood flow or oxygenation to the tissue, which leads to inflammation, oxidative stress, and immune dysfunction. What I'm going to show you is that nitric oxide corrects all those. But I like to go back because I'm not a dentist. I haven't been in dental medicine. I've collaborated with a lot of dentists, but when I look at the dental hygienic practices today of fluoride rinses and fluoride in the toothpaste and use of chlorhexidine for chronic halitosis, how did we get here? And so I looked back historically and go, well, really, this goes back over 100 years ago when the oral systemic link was first established, that there's translocation of pathogenic infectious bacteria from the mouth that cause systemic inflammation that can lead to activation of immune response, inflammation, and then heart attack and stroke. And then actually find dental bacteria, oral bacteria, that can be cultured from the thrombus that cause a heart attack or stroke. So there's translocation of pathogenic bacteria. So the solution was, well, let's use antiseptic mouthwash, let's use fluoride rinses, fluorinated toothpaste, and antibiotics. Now, remember, 100 years ago, we didn't understand what a microbiome was. Today, the entire microbiome has been mapped, and we know that if we destroy the microbiome, to our own demise. So, we've learned a lot in the past 125 years, and we should do better based on the new science. And today that makes perfect sense because the human genome only codes for 23,000 gene products. The microbiome, or the bacteria that live in and on our body, provide 3 million gene products. So this is a true symbiotic relationship. In fact, we're 10 times more bacterial cells than we are human cells. And the microbiome is completely different in the oral cavity versus the colon versus the vaginal flora versus the bacteria that live on the skin. So these bacteria colonize these certain regions of the body to do things that we as humans can't do and to contribute important metabolic factors. And today we know that dysbiosis, microbial dysbiosis, contributes to most chronic diseases. So when we have a disruption in the normal microbiome, it allows for the opportunistic pathogenic bacteria to overtake that and cause dysbiosis and leads to chronic disease. And I like to bring this to everybody's attention because most people don't realize this, especially consumers. But if you just read the back of your fluoride toothpaste, whether it's Crest or Colgate, you can see it, the recommendations are to use a pea-sized amount of toothpaste on your toothbrush because that pea-sized amount of toothpaste has about 0.5 milligram of fluoride. But no one I know uses a pea-sized amount. Most people cover this entire bristle of the toothpaste with toothbrush with toothpaste. So now we're getting 10, 20 times more than the recommended amount, which accounts for 5 to 10 milligrams of fluoride. And this is a poison. In fact, it says here, if you swallow this, call poison control. So fluoride is a poison. It's an antiseptic. It shuts down your thyroid function, and it's a neurotoxin. And there's 200 million Americans that use mouthwash every day. Fluoride is added to about 73% of the municipalities in the U.S. And in 2022, healthcare providers prescribed about 236 million antibiotics. And if you look at those numbers, the common denominator is around 200 million Americans have an unsafe elevation in blood pressure. So this suggested to us, well, is disrupting the oral microbiome causing an increase in blood pressure because it's destroying the nitric oxide producing bacteria? So the question we ask is mouthwash making us sick? And if you look at the data, if you take normal intensive patients, and in this study, we give them mouthwash twice a day for 7 days, and after 7 days, their blood pressure went up about 3 to 4 millimeters of mercury on average. And then that increase in blood pressure was correlated very nicely with a decrease in nitric oxide metabolites. So increase in blood pressure, decreased nitric oxide just from using mouthwash. So then we started trying to figure out what bacteria are responsible for this action, because if we could identify these and harness their activity, we could correct high blood pressure and then protect these bacteria from loss. And so in this study in 2014, we published, and this was a study in collaboration with the University of Texas Dental School in Houston, where we just did tongue scrapings of people walking around the Texas Medical Center. These were some patients, these were faculty, staff, students, and we just measured their blood pressure. We did tongue scrapings and we cultured the bacteria from the dorsal part of the tongue. And you can see here, the people with the greatest diversity in the oral microbiome had the best blood pressure. Those that had the least diverse microbiome had the worst blood pressure, and that we couldn't culture any of these nitrate-reducing bacteria in any of these people. So this is what we call association. It's not causation, but it's a pretty nice association. So then we modified the study, and in this new study, we only enrolled young, normal intensive dental hygienic students and dental students. So as you may imagine, these people are obsessive compulsive about their oral hygiene. They're young, they're fit, they're not on any medication. And so in this study, we just gave them, we got baseline tongue scrapings, we got baseline microbiome, and we got blood pressure measurements. And so we gave them chlorhexidine twice a day for 7 days. Then 7 days later, we brought them back, we did tongue scrapings, measured their blood pressure, and then asked them to stop the mouthwash for 4 days, and then brought them back 4 days later. And what happens to their blood pressure? What happens to their microbiome? And these are the data. This is a figure from the data we published in 2019. In one 21-year-old dental student, 1 week of chlorhexidine, his blood pressure went up 26 millimeters of mercury. So we just by using mouthwash, we made a 21-year-old dental student clinically hypertensive. We didn't change his diet. We didn't do anything but just eradicate the oral microbiome. And then 4 days later, after he stopped, the bacteria reappeared and his blood pressure normalized. And you can see here, we were able to pick up the bacteria that disappeared when his blood pressure went up. And we were able to pick up the bacteria that reappeared the time his blood pressure normalized. And we sequenced the bacteria that were expressing these nitric oxide producing genes, showing that these bacteria are producing nitric oxide and contributing to the regulation of systolic blood pressure, systemic blood pressure. And we could predict the blood pressure in all of these patients by the presence and number of these 4 bacteria. And these are all well-known, well-characterized nitrate-reducing bacteria. So this explained, at least to us, resistant hypertension, because if you have high blood pressure and you go to your doctor, he puts you on an ACE inhibitor, an angiotensin receptor blocker, a calcium channel antagonist, or diuretic, or some other class of medication. But yet we know 50% of those people don't respond with better blood pressure. And the reason is because their hypertension is a symptom of oral dysbiosis. It's not a kidney problem. It's not a renin-angiotensin problem. It's not a dysregulation of calcium. So ACE inhibitors, ARBs, calcium channel blockers aren't going to lower their blood pressure. So now if we take these patients and say, stop using mouthwash, get rid of fluoride, let's support the oral microbiome, 30 days later, they come back and their blood pressure is normal. So in many cases, hypertension is a symptom of oral dysbiosis and a nitric oxide deficiency. So what else leads to nitric oxide deficiency? Well, we know that proton pump inhibitors, PPIs, people who have been on PPIs now have a 40% higher incidence of heart attack, stroke, and Alzheimer's. So these are very dangerous drugs that completely shut down nitric oxide production, cause heart attack, stroke, and Alzheimer's. And what's the mechanism? They decrease stomach acid production, they inhibit nitric oxide production in the stomach, and they increase asymmetric dimethyl L-arginine, which acts as an inhibitor to NOS production of nitric oxide line blood vessels. So you want to know what happens when you completely shut down nitric oxide production, increased risk of heart attack, stroke, and Alzheimer's. And that's what proton pump inhibitors do. So we have to get patients off of antacids. So, okay, let me go back up a little bit, because if we look why people get sick, I've learned, and I think this really good work from Linus Pauling, who said that chronic disease is caused from missing nutrients. I think we can expand upon that by saying it's not only missing nutrients, but it's exposure to toxins that interrupt normal cellular function. And since many toxins come from oral and dental infections, I believe, and have come to learn and appreciate, the dentist and oral hygienist are the most important healthcare practitioners. So if you just look at the NHANES study, you can see that most Americans are deficient in many different nutrients. 75% of Americans are deficient in magnesium, 95% of Americans deficient in iodine, and many other nutrients. And if you're on antacids, no wonder you're nutrient deficient, because stomach acid is required for the absorption of many nutrients: calcium, magnesium, iron, B vitamins. And there are more than 200 million prescriptions written for antacids every year. A third of the population, you don't even have to have a prescription for Prilosec, Prevacid, Nexium. Now you can go to the corner store and get off the over the counter. And 25% of Americans have small intestinal bacterial overgrowth, celiac, leaky gut, causing malabsorption of nutrients. So nutrient deficiency is a real problem. So as I mentioned here, when we started out, the commonalities of all these diseases is hypoxia, inflammation, oxidative stress, and immune dysfunction. So I'll just show you that nitric oxide corrects all of these. So if we look at the lumen of the blood vessel, so this is an ultrasound of the left common carotid, and we can take a picture of the carotid artery going up the neck and get an internal luminal diameter of 0.52 centimeters. And we give our nitric oxide lozenge. 10 minutes later, we dilated this artery by 13%, and that's a 34% increase in blood flow. So nitric oxide, even in contracted, constricted blood vessels, nitric oxide vasodilates, improves perfusion, and overcomes hypoxia and ischemia. What about inflammation? We know that inflammation is the silent killer. And when I look at inflammation, to me, it's when there's an upregulation of adhesion molecules, and then monocytes, T cells, neutrophils start sticking to the lining of the blood vessels. They migrate through They elicit an immune response. You get smooth muscle hyperplasia. You get foam cells and plaque deposition, plaque instability, and plaque rupture. So this entire process is predicated on vascular inflammation. And this is what we saw during COVID, because the spike protein binds to the ACE2 receptor. And in patients who are nitric oxide deficient, they have an upregulation of the ACE2 receptor. So there's more binding sites to the spike protein to bind to, enter into our cells, and replicate and proliferate throughout the body. But this is long COVID. This is the ischemia, the hypoxia, the inflammation, the end organ injury from long COVID. It's all due to nitric oxide deficiency. So we can induce vascular inflammation by diet. This is a paper we published in 2009. You can see here, this is real-time intravital microscopy. This is a very inflamed blood vessel. There's monocytes and neutrophils sticking. This blood vessel is like Velcro. Every there's cells that have migrated through, heightened state of vascular inflammation. Now, in this experiment, we gave nitric oxide and we restored the function of the nitric oxide synthase enzyme in this while giving the same inflammatory diet. And as you can see here, if we can restore the production of nitric oxide, the blood vessel is more dilated. These monocytes and neutrophils don't stick and they don't migrate through. So this is even when eating a bad diet. So if we give nitric oxide or restore the production of nitric oxide, you can eliminate the inflammation from a poor diet simply by downregulating the adhesion molecules, downregulating ACE2. And that's why, some people got sick and some people didn't during COVID, because people who were repleted in nitric oxide didn't get sick, including myself. I've never had COVID, didn't wear a mask, didn't get the shot, and today still never had COVID. And so one of my patents is on a method of reducing C-reactive protein, this acute phase marker of inflammation. So we can check the box that nitric oxide mitigates inflammation. And what about oxidative stress? There's three cellular sources of superoxide and oxygen radicals. There's NADPH oxidase, and here's the paper showing that nitric oxide suppresses NADPH oxidase superoxide production. If the mitochondria become dysfunctional and there's a disruption in the electron transport chain, there's superoxide production. This paper shows nitric oxide and nitrite recouple the electron transport chain and inhibit superoxide production. And then the other source of superoxide is the nitric oxide synthase enzyme. If it's uncoupled, it makes superoxide instead of nitric oxide. And here's our 2009 paper showing that we can recouple the NOS enzyme and prevent superoxide production and enhance nitric oxide production. And really chemically, this is how this works, because superoxide is a radical, nitric radical. And when these two radicals come together, the nitric oxide neutralizes the oxygen radicals and forms OONO minus, called proxy. But this simply changes into nitrate or NO3 minus. And then we have enzymatic systems, glutathione peroxidase and thioredoxin, that take this and reduce inorganic nitrite. So peroxynitrite is not an issue. This is a diffusion limited reaction, and it's how nitric oxide works as an antioxidant. So nitric oxide mitigates oxidative stress. And then when we look at immune dysfunction, there's two phenotypes of macrophages. The M1 macrophages, which we need if we have an infection, if we have a wound or an injury. We want the M1 macrophages to come there, kill the infection, start the wound repair, mobilize stem cells. But we need to turn these off and then turn the M2 macrophages on. And the M2 macrophages are anti-inflammatory. They clean up the debris and damage following infection, and they're anti-atherogenic. Well, nitric oxide is actually the signal that tells M1 to go to M2. If your body can't make nitric oxide, you have a constant overexpression of M1 macrophages and you're in chronic pro-inflammatory state. So nitric oxide polarizes or leads to the regulation of M1 to M2 macrophages. So nitric oxide are hallmarks of all chronic disease, these four hallmarks. So then the next question is, well, can we detect a loss of regulation of blood flow before we get sick? Can we catch this early on before you get symptoms? And this is the work of Daniel Lehman, who uses SPECT scans. And SPECT scans are really looking at how well perfused, in this case, the brain, a brain SPECT scan. And in the left here, you see a nicely contoured brain that shows that all regions of the brain are nice fused. On the right, you've got an Alzheimer's brain where there's holes in the SPECT scans, and those holes are areas where there's hypoperfusion or focal ischemia. There's no blood flow getting to those regions of the brain. So the brain atrophies, you get protein misfolding, and that's what we call Alzheimer's. And then if you look at a patient with a heart attack in this angiogram, this patient had a thrombus in the left circumflex here. There's no blood flow getting this part of the left ventricle. And so this patient went to the cath lab. They aspirated this thrombus, restored blood flow. And if you do this in a timely manner, there's no injury to the heart. And then a little bit deeper into the tissue, and you're looking at sensory or motor neurons. All these neurons have to be supplied with micro capillaries or small blood vessels to get the sodium, potassium in there to elicit an action potential. And as long as there's good endothelial function and these neurons are perfused, then you have normal neurotransmission. When you start to develop microvascular disease, then these blood vessels become diseased, the neurons become dysfunctional, and that's what we call peripheral neuropathy. So every single chronic disease is characterized by decreased blood flow, but if you can restore blood flow in a timely manner, you can correct many of these chronic conditions. So the question was, how do we do this? And that's really the role of nitric oxide. It's a very simple molecule. It's a gas, one nitrogen, one oxygen, but it's more than a vasodilator. In this paper in 2015, it was revealed that nitric oxide is required for oxygen delivery. So when we breathe in air, oxygen binds to hemoglobin, and then when the hemoglobin goes from the arteries to the veins, it senses what we call a P50, and that tells hemoglobin to undergo an allosteric change or conformational change, release oxygen, pick up carbon dioxide, and then we exhale carbon dioxide in the exhaled breath. But unless there's a nitric oxide bound to the cysteine residue on hemoglobin, oxygen will not come off. And you cannot deliver oxygen. You can't pick up oxygen, you can't deliver oxygen. So the cardiopulmonary cycle is a 3-gas system. We need nitric oxide to take up oxygen, deliver oxygen, and exhale CO2. And the Nobel Prize was awarded in 1998 for the discovery of nitric oxide to Bob Furchgott, Lou Ignarro, and Ferid Murad. And as mentioned in the introduction, it was Fred who recruited me to join the faculty of UT Medical School in Houston like 20 years ago, which started my independent research career. And our goal was to understand the mechanism of disease to the extent that we could develop rational therapies. Understand how the human body makes nitric oxide, what goes wrong in people that can't make it, and then how do we fix it. And this was a quote by Val Fuster: "The discovery of nitric oxide and its function is one of the most important in the history of cardiovascular medicine." So there's this growing field and appreciation for longevity and aging, and how do we live a longer, healthier life free of disease. And really what I found is there's 3 objective measures. There's telomere shortening, there's mitochondrial dysfunction, there's loss of stem cell function and repair. And it's nitric oxide that controls and regulates all these. Nitric oxide prevents telomeres from shortening. Nitric oxide induces mitochondrial biogenesis, improves ATP production, the efficiency of oxygen utilization to make ATP. And then nitric oxide is the signal that tells our own stem cells to mobilize and differentiate. So if you can't make nitric oxide and you're nitric oxide deficient, shorter telomeres, mitochondrial dysfunction, and loss of stem cell function. So you get older quicker and you develop disease quicker. When we start to look at the atherosclerosis disease, which is the #1 killer of men and women worldwide, that when you have the ability to produce nitric oxide in the lining of the blood vessels, that prevents the onset and progression of vascular disease. But when you lose the ability to produce nitric oxide, that sets the stage for these structural changes. So then that begs the question, well, how do we control and regulate nitric oxide production, and what goes wrong in people that have lost the ability to make it? And there's 2 ways that we now understand. There's this enzyme called nitric oxide synthase. This electron oxidation of L-arginine, which is an amino acid. We can stimulate this by exercise. And then there's the 4-electron reduction of nitrate to nitrite to nitric oxide that's we can control by the diet and by the oral bacterium and stomach acid production. And I'll take you through each one of these step by step, but this would be the cross-section of a blood vessel. This is the single layer of endothelial cells. This would be the lumen of the blood vessel. And this is the smooth muscle that surrounds all blood vessels. So when smooth muscle contracts, it constricts blood vessels. When smooth muscle relaxes, it dilates blood vessels. So when we begin to exercise stimulates nitric oxide production. It signals the endothelial cells to make nitric oxide. Then the nitric oxide is a gas. It diffuses into the smooth muscle, activates an enzyme called guanylyl cyclase. That enzyme converts GTP into cyclic GMP, and that's responsible for smooth muscle relaxation. And interestingly, this is where the PD5 inhibitors work, the Viagras of the world. Because and a lot of people think that Viagra is a nitric oxide donating drug, and it's not. It's dependent upon nitric oxide, but it does not affect nitric oxide. So nitric oxide increases cyclic GMP. Viagra prevents the breakdown of cyclic GMP. So that's why you're warned against 4-hour erections, because nitric oxide turns the switch on, and the PD5 inhibitors keep it on. But we know 50% of the men that are given Viagra don't respond with better erections. And the reason for that is because they're not making any nitric oxide here to activate this enzyme. So erectile dysfunction in both men and women is a symptom of nitric oxide deficiency. A symptom of nitric oxide deficiency. And this is when we look at the function of the enzyme with age, this is what we're all faced with, or in the normal population. So these are 4 independent studies looking at the function of the NOS enzyme in the lining of the blood vessel as we age. So by the time we're 40 years old, we only have about 50% of the nitric oxide we had when we were younger. And this is what we call endothelial dysfunction. And 50% of the men over the age of 40 self-report erectile dysfunction. So what leads to endothelial dysfunction? And what we've looked at for the past 25 years is the function of the NOS enzyme. And so the NOS enzyme is what we call a homodimer. So it's 2 twins that come together that allow for this flow of electrons to make nitric oxide from this quaternary nitrogen of arginine. But when we have oxidative stress and we oxidize BH4 to BH2, this enzyme becomes uncoupled, and now we're producing superoxide through this enzyme instead of nitric oxide. So oxidation of BH4 is what leads to NOS uncoupling. So then the question was, well, how do we prevent BH4 oxidation? How do we prevent an electron loss from tetrahydrobiopterin? A little bit of physical chemistry. Because there's an electrical potential that's required to extract an electron. So oxidation is a loss of an electron, reduction is a gain of an electron. These oxidation reduction reactions occur every day, every second, in every cell in the body. But the redox potential for BH4 is much different than glutathione or ascorbic acid or alpha lipoic acid. So we have to understand the redox potential to prevent BH4 oxidation. And that's what we're able to do and restore endothelial function. And this is where the dental community comes in, because this human nitrogen cycle that's fueled by our diet, primarily green leafy vegetables, the nitrate in these green leafy vegetables is absorbed in the gut. 90 minutes after we consume this, it's concentrated in our salivary glands. Now, when we secrete, we salivate, we're secreting nitrate. On the dorsal part of the tongue are nitrate-reducing bacteria that perform this 2-electron reduction of nitrate to nitrite. Now we swallow our own saliva. The pKa of nitrite is 3.4. So in the acid environment of the stomach, nitrite becomes nitric oxide. So this entire pathway can be fueled by diet, but it's dependent upon oral bacteria and it's dependent upon stomach acid production. So we'll take these step by step. So how much spinach, lettuce, celery would I need to eat to get enough nitrate to manage my blood pressure? And so to answer that question, we went to 5 cities across the US, Chicago, Dallas, Los Angeles, New York, and Raleigh. We published this 10 years ago. But the answer was pretty complicated. And if you just, this is a table from the paper, but if you look at celery, if you lived in Dallas or Los Angeles, you could go to your grocery store and buy 4 to 5 stalks of celery, eat that, get enough nitrate to theoretically manage your blood pressure. If you lived in New York, you'd have to eat 30 or 40 stalks of celery. So what this told us, we really can't make recommendations because there's regional differences in the nitrate content of vegetables. And if you just look across vegetable categories, I mean, celery has much more than broccoli, for example, and cabbage. So it depends upon where you live and what you're eating. And these are conventionally grown vegetables. When we look at organically grown vegetables, you can see the numbers are much lower. In fact, about 5 to 10 times less nitrate in organically grown vegetables than conventionally grown vegetables. Because to get an organic label, you can't add nitrogen-based fertilizers to the soil. Without nitrogen, there's no nitrate to assimilate, and organically grown vegetables are typically nutrient depleted. They don't have herbicides or pesticides, but they're typically not replete in most nutrients. So that's number one. Number one, we're not getting enough nitrate in our diet, and it's impossible to determine if you are, because it depends on what you're eating, where you live, where the vegetables are grown. But the other problem is the use of mouthwash. 2 out of 3 Americans use antiseptic mouthwash. Most people use fluoride toothpaste. 200 million Americans use antacids. 200 million prescriptions written for antibiotics every year, completely disrupting this nitric oxide production pathway. Now, let me take you through this experiment, because this was my eureka moment in science. And so we were just trying to figure out if we could enhance nitric oxide production in the heart in patients who have a heart attack, can we protect them from dying from sudden cardiac death? And can we protect the heart from injury from heart attack? Because some people have a heart attack, sudden cardiac death. They're dead, it's over. Other people have a heart attack, they survive it, but they develop heart failure, and the heart's only functioning at, say, 10 to 15% of normal capacity. And then some people have a heart attack, no injury, normal cardiac function, normal ejection fraction. So we thought, is nitric oxide responsible for this? So to answer this question, we overexpress, and these are mouse experiments, these aren't experiments. We can transfect the nitric oxide synthase enzyme in the cardiac myocytes. And you can see here the Western blot, it's a successful transfection. The enzyme is active, it's pumping out a lot of these nitric oxide metabolites. And in these mice, if you give them a heart attack, so we do open heart surgery, we tie a ligature to the left anterior descending artery for 1 hour, so completely shut off blood supply, we call the widowmaker, way up high in the LAD, for 1 hour, and then we cut the ligature, we perfuse the heart for 24 hours. These hearts do not see any injury. In fact, the mice survive, and there's no injury to the heart. And if we look at the blood of these mice, these transgenic mice, they have an elevation in nitrite and nitrate. We harvested the liver and found that the liver looks similar to the heart. Now, what may not be obvious is nitric oxide that's produced in the heart, once it's produced, it has a half-life of less than 1 second. So it can survive transit to the liver. But something is mediating this nitric oxide biochemistry from the nitric oxide produced in the heart. And the liver biochemistry was changed. It's not because there's an overexpression of the NOS enzyme in the liver. It's a transport function. So then the next question was, what does this mean? Does it mean anything? So we shut off the blood supply to the liver of these cardiac-specific transgenic mice for 1 hour, and then we reperfuse for 5 hours. And you can see we could actually protect the liver from injury from nitric oxide that was produced in the heart. This was the first demonstration that nitric oxide, that if we could generate nitric oxide in a single biological compartment, it has a transport function that protects the liver, the kidney, the brain, the lungs, every organ, every tissue, and every cell in the body. So the light went off for me is, well, all I have to do is generate nitric oxide anywhere in the body. And so the oral cavity is the most non-invasive, most accessible biological compartment we have access to. So I thought, well, can I make a nitric oxide delivering or nitric oxide generating lozenge? So here's our paper in 2007, and the proceedings is nitric oxide is a hormone. And it took us about 1.5 years to publish this paper because the reviewers didn't believe us. So we had to go through this exercise of checking boxes. So what's a hormone? It's a chemical substance. Well, nitric oxide is a chemical substance, 1 nitrogen, 1 oxygen. It acts as a messenger in the body. Well, the Nobel Prize was awarded for the discovery of nitric oxide as a signaling messenger molecule. Activates soluble guanylate cyclase, posthumously modifies proteins affecting their structure and function. So it signals. Hormones travel from one part of the body to the other. And in this study, it's not nitric oxide gas because, again, the half-life is too short. But nitric oxide is transported as inorganic nitrite, and it binds to the cysteine residue of glutathione and is transported as an S-nitrosoglutathione. So that's the hormone endocrine functions of nitric oxide. And then it helps control how cells and organs function. Well, nitric oxide leads to blood vessel dilation, improving circulation, oxygen delivery, mobilizing stem cells, preventing telomeres from getting shorter, and improving mitochondrial function. So when we check all boxes, the conclusion was nitric oxide is a hormone, unequivocal evidence, changed the way we thought about nitric oxide-based therapies. So here's kind of what the overall conclusion of that paper was. Nitric oxide is a hormone. It's transported as nitrite and S-nitrosoglutathione, improves blood flow, reduces inflammation, oxidative stress, and immune dysfunction, and improves mitochondrial function. So then as we started to develop nitric oxide-based product technologies, we looked at the market and found the market was flooded with so-called nitric oxide products. And there were a lot of beetroot products on the market. There were people selling potassium nitrate in capsules. And I just want to bring the analogy to you because one of my pet peeves is if patients that have hypothyroidism, they go to their endocrinologist and they give them Synthroid or levothyroxine, which is T4, which is an inactive enzyme. T3 and T2 are actually active thyroid hormones. T4 is inactive. Nitrate is completely inert in humans. The problem in people who have hypothyroidism, even T4, they can't convert T4 to T3 because of the lack of iodine. Same thing here. If you give a patient nitrate, they don't have the right oral bacteria. They use fluoride in their toothpaste or mouthwash or antibiotics or antacids. They can't convert this into nitric oxide. So nitrate is inert in humans and is not a practical measure or a practical way to replete nitric oxide. And then some of these companies have an issue with simple addition in mathematics because we need at least 300 to 400 milligrams of nitrate to see changes in blood pressure. And I've measured every single beetroot product on the market. Most of them contain no detectable nitrate. So these are what we call dead beets. But even the highest concentration of beet powders only contain 5 to 9% nitrate. So to get that 300 to 400 milligrams, you would have to give 3 to 6 grams, 3,500 to 6,000 milligrams of beet powder. And there are companies out there telling you, oh, take these 2 capsules of beet, 700 milligrams, to get nitric oxide. The numbers don't work. These people are either naive, ignorant, or deliberately deceiving you to buy their product. But this can't work. And then there are a number of products that have arginine and citrulline in them. Again, we're never deficient in arginine or citrulline. Citrulline is a byproduct of nitric oxide production. It's not a precursor. Arginine can activate herpes virus. There's at least 2 trials where if you give high-dose arginine to post-infarct patients, it killed more people than placebo. So this 2006 study, the conclusion was arginine should not be given to post-infarct patients. It caused more death than placebo, increased mortality. Same thing happened in patients with peripheral heart disease. You give arginine to patients with PAD, they get worse. So arginine is not the problem, and it's certainly not the solution. So to fuel this nitrate, nitrite, nitric oxide pathway, you must consume nitrate, must have the optimal oral microbiome, must have stomach acid production, must have optimal salivary secretions. So there's a lot of steps in this process that go wrong that lead to nitric oxide deficiency. And then there are companies out there selling you grapeseed extract, resveratrol, acetylcholine, epicatechins. But again, these require the enzyme to be coupled and functional. You can activate or stimulate till the cows come home, but if this enzyme isn't coupled, you're not going to get any nitric oxide from the other end. So that's where we came in, because our whole thought process was if your body can't make nitric oxide, then we have to do it for you, right? It's like it's hormone replacement therapy. If you're a man with low testosterone, your doctor doesn't give you DHEA or pregnenolone and hope your body can make testosterone. No, people would laugh at that. They give you testosterone. Same thing with women. If you're low in estrogen or postmenopausal, they give you estrogen or estradiol or an active form of estrogen. They don't give you precursors and hope your body can make it. And so that's what we do. If your body can't make oxide, we make an orally disintegrating tablet, releases nitric oxide gas in the oral cavity, goes systemic. We see dilation of the carotids within 12 seconds. We make a fermented beet powder because we felt an obligation and really responsibility to deliver a beet powder. If people were looking for beets that produce nitric oxide, then we felt an obligation we could deliver that. And then we make a topical nitric oxide for skincare, for beauty, fine lines, and wrinkles. And now we're developing that as a topical drug. So I like to, what we do is hormone replacement therapy. I've demonstrated to you nitric oxide is a hormone, that we have to replace this critical hormone. And again, I don't want to, this would be humorous if it wasn't so serious, but there's no endocrinologist that would give a type 1 diabetic insulin's 21 amino acid peptide. If you're insulin dependent, would anybody give you 21 amino acids and say, well, let's close our eyes and cross our fingers and hope your body can make insulin? No, you give them insulin. Same thing, the analogies I use, testosterone, estrogen, thyroid. And that's what we do that nobody else can do, is we deliver the bioactive gas. We don't give you precursors, we don't give you substrates and hope your body can do it, because most people can't. In fact, that's the reason they're nitric oxide deficient. And here are the data. We put the lozenge in the mouth, we put a nitric oxide analyzer, and we can detect nitric oxide gas coming off out of the oral cavity. When the lozenge is fully dissolved, the nitric oxide goes away. We see 11% plaque regression, taking the lozenge twice a day for 6 months. And then let me finish up with this clinical story here, because this was a really amazing, life-saving story in this 5-year-old kid who was born with what's called an inborn air metabolism. This kid was born without arginosuccinate I. It's part of the urea cycle enzymes, and their primary problem is hyperammonemia. So it's a urea cycle disorder. But even though they're treated with drug therapy and protein restriction, these kids will develop liver disease and cirrhosis and have to get a liver transplant at 7 or 8 years of age, or they'll die from liver failure. They have blood clotting disorders. They're prone to heart attack, stroke. They have neurological dysfunction. They have high blood pressure, kidney disease. They have systemic disease that couldn't be explained by the underlying disorder. So these physicians came to me in 2006, help us understand this. And in 2011, we solved this riddle. We published this in Nature Medicine. But it was the ASL enzyme that tethers and anchors the eNOS enzyme to the membrane. These patients who don't have ASL, this protein complex falls apart, and there's no nitric oxide being produced in these patients. And when you look at their symptoms through the lens of nitric oxide deficiency, of course that explains the liver dysfunction, portal hypertension. Of course it explains the blood clotting disorders. Of course it explains the resistant hypertension, the kidney disease. So now the question was, can we rescue these patients with a genetic disorder simply by giving them nitric oxide? And here's the answer. This was a paper we published in 2012, but here's the lifelong blood pressure profile of this 5-year-old kid. He was put on polypharmacy, very uncontrolled resistant hypertension for 10 years. When we saw him at Texas Children's Hospital in February of 2010, his blood pressure was 210 over 115. He was in the pediatric intensive care unit, and nothing would lower his blood pressure. So at that time, we knew it was a nitric oxide problem, so we started dosing him with isosorbide dinitrate, ISDN. 20 milligrams. 4 days later, his blood pressure normalized. He was released from the hospital, sent home, and he started taking 20 milligrams 4 times a day, developed tolerance to these drugs. And in February of 2011, he came back to Texas Children, his blood pressure 185 over 110. And now the docs were out of bullets. They'd tried everything in their armament to normalize his blood pressure. So I saw him and I gave him a lozenge. 4 hours after I gave him a single lozenge, his blood pressure went to 130 over 80. And we got him off all prescription medication. He was taking the lozenge once every 4 to 5 hours. And we published this in 2012. But this nitric oxide generating lozenge saved this kid's life when all other prescription medications had failed. His kidney disease resolved within 5 days. His heart disease completely resolved within 5 months. So I mentioned nitric oxide mobilizes stem cells. When we give nitric oxide, we mobilize stem cells, and we increase the number of circulating stem cells. And within 5 months, his heart disease is completely resolved. So then I like to show this case study because I've showed you nitric oxide is important, but it's not an end-all be-all cure-all. You still have to address the fundamental issues in these individual patients. And so in this case study, we had to address all of these. We had to address dental infections, use restorative dentistry, apply voltage, apply nitric oxide, good nutrition. And this particular case study is my dad. My dad's in a wheelchair. He had a car accident in 1984. So he's been paralyzed, a T11 compression injury, for 41 years now in a wheelchair. And years ago, probably 10 years ago now, he had hemorrhoidectomy surgery, and his surgeon told him to facilitate healing and go sit on a heating pad 30 minutes 3 times a day. And when you take a diabetic paraplegic patient on a heating pad, you cook him without him knowing. So this was the next day when Dad sat on a heating pad. It didn't really manifest until 24 hours later. But this is a picture I took coming out of the operating room where they'd done a skin graft over this wound. Obviously, very serious injury. They didn't expect him to survive it because of the risk of infection. But they did a colonostomy, diverted the waste material. And so I was concerned, and the doctors were concerned the skin graft wouldn't take because there's no blood to this paraplegic diabetic patient. So at night, I started applying a topical nitric oxide, a nitric oxide releasing gauze, over this graft to try to heal this wound. And so the doctors told me he probably wouldn't heal. If it healed, it'd take 9 or 10 months. He's probably going to die from this wound and infection. But this was 3 months later. Completely healed this wound simply by putting nitric oxide on it, getting blood flow to that graft, and killing the infection. But when they grafted over this and we healed the wound, he had a decubitus ulcer. This is a right ischial ulcer. And this was kind of taken sideways. But I could put a tennis ball in this wound and I could see his bone underneath his right butt cheek. So this is a stage 4 non-healing wound. Took him to all the wound care centers that I knew of. Everybody told me there's no way you're going to heal this wound. He'll eventually get septic and die from it. So this is today, and we healed this 4-year-old non-healing wound in less than 6 months. But this is what Dad had a number of mercury amalgam fillings. He had several root canal teeth that I took and had the root canals extracted, the infections cleaned up, ozone therapy, platelet-rich fibrin into the extraction sites. On the wound itself, I did red light therapy. I put him in an infrared sauna to help detoxify him. Topical nitric oxide, we took stem cells from Dad's adipose tissue, injected it in the wound, grew enough tissue to finally close it with a surgical flap. But the point I want to make here is really the thing that turned the corner was the restorative dentistry. Getting all the metal out of Dad's head and getting all the infected root canals cleaned up. And that is really what turned the tide. So an amazing story. I mean, it's a very personal story, but that told me that this was critically important, what we're doing. So now we're moving into drug therapy. We're developing a drug for Alzheimer's. As I showed you this picture before, Alzheimer's is a metabolic disease. It's a vascular disease. All drug therapies for Alzheimer's have failed. It's because they're targeting the amyloid plaque and the tau tangles can't work because those are consequences of the disease. They're not causing the disease. But Alzheimer's is a metabolic disease. We call it diabetes type 3. And Alzheimer's have focal ischemia, inflammation, oxidative stress, and immune dysfunction. What does nitric oxide do? Improves insulin signaling, overcomes metabolic disease, improves cerebral blood flow, perfusion of the brain. We've got before and afters on SPECT scans of the drug therapy. And we reduce inflammation, oxidative stress, and immune dysfunction, and we prevent proteins from misfolding. So nitric oxide therapy provides the solution to the root cause of Alzheimer's disease. I'm absolutely convinced our nitric oxide drugs will completely eradicate Alzheimer's. In our topical drug, I've been able to duplicate and replicate Dad's healing effects with our topical nitric oxide in dozens, maybe hundreds of patients now. This is a 3-year-old non-healing diabetic foot ulcer. We healed it in 30 days. 2nd-degree burn, 21 days later, applying this twice a day, completely healed with no scar formation. And then here's another 64-year-old paraplegic diabetic at Yale Medical Center that was treated. 4-year-old non-healing wound, applied a serum, we completely healed it in 195 days. So let me just wrap up here and we'll open it up for some questions. But you know, the science is very complex, but I tell people the strategies to restore nitric oxide can be simple. You just got to stop doing the things that disrupt it and start doing the things that promote it. We have to get rid of fluoride and antiseptics and stop killing the oral microbiome. We have to get patients off of antacids, and we got to stop eating sugar and high carbohydrates. Glucose binds to proteins and glycates enzymes and shuts down nitric oxide production. If you stop doing the things that disrupt nitric oxide production, throw in a healthy diet in moderation, physical exercise, infrared sauna, 20, 30 minutes of sunlight a day, and then when all else fails, we have products to do it for you. So I think these are fundamental truths we've discovered over the past 25 years. And, truths go through pose, and then thirdly, they're accepted as being self-evident. And I've certainly been ridiculed. I've been violently opposed. I've been sued. I've been come after. But, I know that this is going to be self-evident in the very near future. And then the greatest enemy of knowledge is not ignorance, it's the illusion of knowledge. There are a lot of companies, a lot of people out there who have an illusion of knowledge. And it's dangerous, quite honestly. So if I wanted to create a recipe to make you the #1 customer of Big Pharma, to get you sick and dependent upon drug therapy for the rest of your life, I would recommend the government's food pyramid. Consume a lot of sugar, grains, carbohydrates. Don't exercise. Don't sweat. Put fluoride in our municipal water. Put it in the toothpaste. Get your cholesterol below 200, so you can't make vitamin D. You become immunocompromised. Can't make testosterone. Can't make estrogen. Take antacids, so you can't absorb nutrients. Use antiseptic mouthwash every day, sometimes 2 to 3 times a day. Get root canals and follow the government recommendations. And unfortunately, that's what a lot of people, it seems funny, but I know people that do this, that are checking 8 of these boxes, and drug therapy isn't making them better. They're sick, they're dying, and the system has failed them. And I just show this because this is a biochemical pathway I created or discovered more than 20 years ago. Because if you don't know where nitric oxide goes and what it becomes, and you can't control and dictate the metabolic fate, then you can get some side reactions that may have unwanted effects. So all these companies out there, if they don't understand what nitric oxide is, what it does, what it becomes, and where it goes, really have no business making or selling a nitric oxide product. So to conclude, hopefully I've convinced you nitric oxide controls and regulates oxygenation, circulation, and inflammation. There's this age-related decline in nitric oxide that can lead to onset and progression of disease. We must use safe and effective nitric oxide products in order to optimize our health. And longevity and health span begins in your mouth. So what does the future look like? I think we're seeing this today. Dentists will be recognized as the primary drivers of health and/or disease. And dental medicine will selectively eradicate pathogens while supporting the healthy microbiome. And we've done this. We've launched a biome-friendly toothpaste recently to selectively kill the pathogens, the gingival bacteria, while supporting the bacteria that live in the crypts of the tongue. We're launching a nitric oxide-friendly mouth rinse in a couple of months. But there has to be an open collaboration between dentists and physicians to coordinate personal care. And I truly believe and convinced nitric oxide will be a cornerstone therapy for most, if not all, chronic diseases. So with that, I'll leave 10 minutes for questions. If you don't get questions answered, here's my contact information. There's my email. I encourage you to subscribe to my YouTube channel where we put content, education, information up. This is my latest book I just launched a couple of weeks ago, or actually a couple months ago, Secret of Nitric Oxide. It really tells this 25, 30-year journey of what nitric oxide is, what led to a Nobel Prize, what leads to a loss of nitric oxide production. And in this book, I kind of intertwine my own personal story of discovery in that, but it's highly recommended. It's #1 on Amazon. We're moving up the New York Times. But it really contains all the information you need about nitric oxide. And then for product information, n101.com, or for wholesale information, you can email wholesale@n101.com. So thank you very much for your attention, and happy to ask questions, or just shoot me an email if we don't get your questions answered.
Wonderful, wonderful. Thank you so much, Dr. Bryan. That was wonderful. I'll leave that up for just a minute for people to get. And I am going to start with our first question. After that amazing presentation, I feel like I have learned so much, and I want to go back and watch again. Based on your research, what future directions do you foresee the integration of nitric oxide science into mainstream medical practice? Because it sounds like we're getting there. and particularly regarding the oral systemic health connection. And honestly, even seeing that story about your father and the unique ways of using it, I think there's a lot ahead of us here.
Yeah. No, look, I think without a doubt, nitric oxide will be the cornerstone of therapy. The reason it hasn't been is because there's no FDA approved drug for nitric oxide. There are all these supplements on the market. As I told you, 95, 99% of them don't work. So they shouldn't be integrated into clinical care because they don't do anything. But I think as we move forward with the FDA and get our drugs through the FDA approved and on the market for specific indications, there'll be number one, a growing awareness. But number two, there'll be, even for standard allopathic physicians, they still go by the model of make a diagnosis, write a prescription, and treat that patient with a prescription. And we're going to give them the tools they need to do that, to safely and effectively do it, and actually have a prescription medication that actually makes people better. But I think as we start to develop these drugs and get them on the market for drug therapy, people will start using these off-label. But we're going to continue to go for specific indications: heart disease, Alzheimer's, pulmonary hypertension, congestive heart failure, topical drugs for diabetic ulcers, non-healing wounds. And really the list is limitless, because I don't see an indication where nitric oxide at the right dose at the right time in the right patient wouldn't provide benefit.
Yeah, absolutely. I love hearing that. You have shared some of your consumer products, which I'm excited to try out myself, and some interventions that are currently available. And I just want to know, how do people evaluate their effectiveness? Like what are some of the key factors that they can look for in saying, okay, what I have is working for me?
Well, that's been the challenge, because nitric oxide is a gas that's gone in a second. 15 years ago, I developed a salivary test strip where we test the saliva, and we get a colorimetric change based on some old chemistry called the grease reaction. And we used that for a number of years, and I abandoned the patents on them, and now there are a number of companies that are out there selling those test strips. But I don't use them anymore, especially in the community, because an active oral infection is going to light that test strip up. So systemically and clinically, these patients are completely devoid of any nitric oxide, but they use that test strip and light it up and turn it bright pink. And it's really a reflection of an oral inflammation and infection rather than systemic nitric oxide availability. But in terms of looking for products, I always tell people, look for companies that have a basis in science. If products don't have a scientific advisory board, or they don't have anybody who they're so formulator who's never published a paper on PubMed or in basic science, then they probably don't understand nitric oxide biochemistry and enzymology to the extent they can make a functional product. And people forget, Big Pharma has been working on this for 30 years. I consulted early on with the GSKs, the Bayers, the Merck in the early 2000s to develop nitric oxide-based therapies. And they failed. And now there's people, former insurance salesmen and journalists who are and people off the streets putting ingredients in a bag and calling it nitric oxide. I mean, to me, it's humorous, and it's doing the field a disservice, because the problem is, and this is a real problem, because I talk about nitric oxide and people go, well, Nathan, I took a nitric oxide product for years and it didn't do anything for me. So nitric oxide doesn't work for me. And that's the worst interpretation they could make. Nitric oxide always works. Nitric oxide vasodilates, it mobilizes stem cells. But because that product didn't improve their nitric oxide or provide nitric oxide, that product failed them. Nitric oxide didn't fail them, but more importantly, that company failed them. And those companies should go away. Make your vitamin C's, your vitamin D's, the simple things, but leave nitric oxide to the people who understand the science. Because again, it could kill an entire industry.
I think I want to even go on that a little bit more and ask you, what do you see as the biggest misconception among both the medical community and the public regarding nitric oxide's role in systemic health?
Well, in terms of consumer perception, it's, because you can go to GNC or drugstore or compounding pharmacy, and there's dozens of products that are labeled as nitric oxide. And most of them are arginine, citrulline based, but understand that the problem with nitric oxide deficiency is never a deficiency of arginine. It's the enzyme has lost the ability to utilize arginine to make nitric oxide. And then the other thing is people are putting beet powders in there, and 90% of the beet powders on the market don't contain any detectable nitrate or nitrite. The only thing they do is turn your pee and your poop pink and cause a lot of anxiety. There's no nitric oxide benefit to any of it. So it confuses the marketplace. And then, when you look at physicians and you've got these so-called biohackers now with no science or medical pedigree or understanding out there pitching products and that are influencing millions of people and giving them misinformation. And then physicians buy into this because I guess they're paying them or giving them margins, and they're incentivized by the money rather than the science. So I think it's a huge problem. But to get around this, I coined a new term called nutraceuticals. So we're not nutraceuticals because nutraceuticals are providing missing nutrients. We're nutraceuticals because we provide nitric oxide. We can detect it, we can quantify it, we can verify it coming off all our products. And so as we go through a rebranding, look for nutraceutical products because those are developed by me. I've trademarked the term. Spent 25 years in science. I understand the biochemistry, the enzymology, where almost all, probably I would say all other companies fail to have that type of expertise in their product development. They're Me Too products.
Wonderful. I have one last question, just out of curiosity. I know in the myofunctional therapy world, we talk a lot about humming and the nitric oxide that you can get from that. Do you have anything that you can add to that? Is that a benefit that is worth us humming every day and getting some nitric oxide production from that?
Absolutely. But it's dependent upon the function of the enzyme. So when we talk about the function of the NOS enzyme in the endothelial cells, that same enzyme is in our epithelial cells. And there's some beautiful done that certain frequencies of humming can stimulate nitric oxide production, and we can pick it up in the exhaled breath. And that resonance frequency is dependent upon the volume of the nasal sinuses into the oral cavity. So the frequency may be different for different people. And then same thing with nasal breathing. If you do nasal breathing, it can stimulate the enzymatic production of nitric oxide, but we have to recouple the enzyme and make it functional. Because again, in young, healthy people with good endothelial function and good epithelial function, you do nasal breathing, we can detect a lot of nitric oxide. You take older patients with endothelial dysfunction, you do nasal breathing, there's no nitric oxide because we got to focus on fixing the enzyme. And that's what my products do. They recouple the enzyme. So now if you do humming at certain resonance frequencies, and if you do this, we can produce nitric oxide, deliver it to the lower airways, and lower pulmonary pressure, normalize blood pressure. And it's a great way to enhance nitric oxide.
Incredible. Thank you so much, Dr. Bryan. I really appreciate it, especially given that you had, your travel concerns and stuff today. So I'm really glad that you could still join us and give us such an amazing presentation. I'm excited to get your book and read that, and also to try out some of those products. So thank you so much. I feel like we learned a lot about nitric oxide that we did not know. And I think that we'll be seeing a lot more about it in the future and with your company too. So thank you so much for joining us and sharing that with us today. I do just want to make a couple of announcements before we wrap up.
I'm gonna sign off with your permission. I'm 3 minutes late to my next meeting.
Absolutely. Thank you so much, Dr. Bryan. I appreciate it. Thank you again. Have a good rest of your day. All right, everyone. So I just wanted to thank you all for joining us for this Thursday Night Live. If you are not a member, you can join Airway Circle's membership today at airwaycircle.com/membership. And then we have our Foundations of Foundations of Orofacial Myofunctional Therapy waitlist open, and that is for August 1st of 2025. And yes, I'm bringing up 2026. Our MyoCircle waitlist is open for our January 1st, 2026 cohort. So we hope to see you there. And thank you guys so much for tuning in. Have a great rest of your